Reaching orbit is a notoriously unforgiving process. Historically, the early years of the private space industry have been defined by expensive wreckage and launch pad fireballs. Even SpaceX, the current global leader in launch frequency, saw 3 consecutive orbital attempts fail before they finally reached space with their Falcon 1 rocket. But on July 18, 2026, Skyroot Aerospace broke that pattern. Their Vikram 1 rocket successfully launched from Sriharikota, carrying its payload into a 450-kilometer low Earth orbit. Skyroot achieved a flawless orbital insertion on their very first attempt. It is an engineering milestone that has eluded even the most well-funded space startups. By bypassing the typical cycle of early catastrophic failure, Skyroot has effectively reset the timeline for how quickly a private entity can achieve orbital capability. For its maiden flight, Mission Aagaman, Skyroot bypassed the standard practice of using a dummy mass, choosing instead to fly a live commercial payload. The rocket deployed active customer hardware, including operational satellites and a robotic arm, specifically designed for the removal of space debris. This success signals India's entry into the global launch market not with an experimental prototype, but with a functional product ready to compete for commercial contracts. To reach orbit on the first try, Skyroot moved away from the heavy, legacy steel designs traditionally used in Indian state-run rockets. This diagram shows the core of their design, a 7-story carbon composite orbital vehicle. This material is 5 times lighter than steel, with a higher strength-to-weight ratio. That lightweight airframe is powered by solid fuel boosters and the 3D-printed Raman 1 liquid engine, significantly reducing manufacturing complexity. This combination of mass-efficient materials and simplified manufacturing allows the Vikram 1 to carry up to 350 kilograms of payload into low Earth orbit. These choices function as a direct economic strategy to offer launch services at a price point challenging the models of existing global providers. This first-try success was enabled by a structural advantage that most Western startups lacked in their early years. In 2020 and 2023, India overhauled its space policy, opening ISRO's infrastructure to private companies. This chart shows the direct result of those reforms, as India's space startup ecosystem grew from a single company in 2014 to more than 400 by early 2026. These reforms allowed Skyroot to utilize existing government launch pads and a network of 400 domestic suppliers, saving the company from the massive capital expenditure required to build basic infrastructure from scratch. This integrated public-private model provides Indian startups with a capital efficiency that gives them a significant head start over international rivals who were forced to fund their own early logistics. The success of Vikram 1 officially transitions India's private sector from a component supplier to a developer of complete orbital-class launch systems. Satellite operators seeking a ride to low Earth orbit now have a cost-effective Indian alternative that has proven it can perform under real flight conditions. This projection shows the scale of the national ambition. The Indian government is leveraging these private capabilities to expand its space economy from $8.4 billion today to $100 billion by 2040. Vikram 1 serves as the proof of concept required for the country to capture a meaningful share of that projected global commercial space market. Skyroot is already moving toward larger segments of the market with the development of Vikram 2, a heavier vehicle designed for payloads of up to 1,000 kilograms. Their long-term roadmap also includes reusable launch boosters, a technology designed to further decrease the cost of reaching orbit. With a successful commercial mission now validated, India's private space sector has established itself as a credible competitor. It now possesses the engineering and the infrastructure to become a permanent fixture in the global business of space exploration.